Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 7, Associated Ratios and the Value of a Ratio. So here's our first example. It says, which of the following correctly models that the number of red gumballs is 5/3 the number of white gumballs? So see if you can choose the right answer here. There are four choices. It's multiple choice. Which one of these tape diagrams represents red gumballs being 5/3 the number of white gumballs? Pause the video, see if you can figure this out. Okay, so now that you've tried this, well, red gumballs is 5/3 the number of white gumballs. 5/3 is the same as saying 3/3 plus 2/3, which is the same thing as saying 1 and 2/3. Which is 1 and 2/3. So that means there are 1 and 2/3 gumballs of red gumballs for every white gumball. Okay? 1 and 2/3 gumballs for every white gumball. So if I think of that, then I know that there are more red than white. So I'm going to eliminate D. I'm going to eliminate A. So now I need to find which one represents my ratio. Well, we have 5:3, and we have 5 squares here, and we have 3 squares here. We have 3 squares here, we have 2 squares here. So what does 1 and 2/3 to 1 mean? Well, if I choose a white square, a 1 white square, I'll shade one whole white square. Let's look at it this way. I just want to be really thorough with this explanation. So I chose one white square. Well, how much am I going to shade of the red if I shaded one of the white? It's going to be 1 and 2/3. So I'm going to shade all of this one, just like I did. And then if I break these up into thirds and shade 2/3 of it, then that's how much I shaded with respect to this one. Now I'm going to do it again. I'm going to shade one whole white one, which is the same as this one here. And I'm going to shade, here's 1/3 here, so that's shading 1/3. And then if I shade all of this, that's 1 and 1/3. But I need 1 and 2/3, so I need one more third, so I'll shade that. And then finally, if I shade the third one white, for every white, there's 1, and 2/3 gumballs. So that filled in my entire tape. So this is 1 and 2/3, this is 1 and 2/3, and this is 1 and 2/3. So the answer is B. This is 3:2, which would be 1.5 per 1. Okay, so that's another way of looking at how to determine. So realistically, if you see this 5:3, it does come out to be the number on top is first, the number on bottom is second. So there's 5 here, and there's 3 here, and so that's 5/3. Okay. Example 2. The duration of 2 films are modeled below. Film A, which has a total of 5 squares, and film B has a total of 7 squares. The ratio of the length of film A to the length of film B is 5:7. Just like up above here, I changed that 5/3, or actually I hadn't shown it that way. It would also be 5:2:3. For every 5 red gumballs, there are 3 white. Okay, the length of film A is, so now we're going to make it a fraction just like the last problem. The first number in your ratio is your numerator, and the second number is your denominator. Just like looking at the tape diagram, the top number stays on top, the bottom number goes in the denominator. And then it says the length of film B is of the length of film A. So the thing we are talking about first always goes in the numerator. So now we're saying the length of film B is going to come first. So that's 7. And to film A, the length of film A is 5. So it's just the reciprocal, 7 to 5. Okay, moving on. Exercise 1. Sammy and Caden went fishing using live shrimp as bait. Sammy bought 8 more shrimp than Caden bought. When they combined their shrimp, they had 32 shrimp altogether. How many shrimp did each boy bring? So what I would do is, we're talking about Sammy and Caden, so I'm going to write Sammy and Caden went fishing using live shrimp as bait. Sammy bought 8 more shrimp than Caden bought. When they combined their shrimp, they had 32 shrimp altogether. Okay? Sammy bought 8 more shrimp than Caden. Their total is 32. So how could we do this with a tape diagram? Is this possible with a tape diagram, or is there an easy way to do this? Okay, I'm not going to do this using a tape diagram. What I'm going to do is I'm going to write this out as an equation. So Sammy plus Caden, the amount Sammy bought in shrimp plus the number of shrimp Caden bought equals 32. But Sammy bought 8 more shrimp than Caden. So I'm going to replace Sammy with Caden plus 8. Okay, Sammy bought 8 more shrimp than Caden. So if Caden bought 1, Sammy bought 8 plus 1, which is 9. If Sammy bought 2, and if Caden bought 2, then Sammy bought 8 plus 2, which is 10. So if I replace Sammy with Caden plus 8, because that's what it is, Sammy bought 8 more shrimp than Caden. So if Caden bought a shrimp, Sammy bought 8 more than that. So it's the number of shrimp Caden bought plus 8 is Sammy. And then if I do this, that equals 32. So if I add all this up, I get K plus K, which is 2K, plus 8 equals 32. And then if I subtract 8 from both sides, I'm going to get 2K equals 24. And then if I divide 2 on both sides, I get K equals 12. So Caden bought 12 shrimp. And Sammy bought 12 plus 8 more shrimp, which is 20 shrimp. And 12 plus 8 is, 20. 12 plus 20, Caden shrimp 12, Sammy shrimp 20, totals 32 shrimp. And that is what we wanted to get. Okay? B. What is the ratio of the number of shrimp Sammy bought to the number of shrimp Caden bought? Okay. Number of shrimp Sammy bought was 20, and the number of shrimp Caden bought was 12. So the ratio of Sammy to Caden is 20 to 12. Express the number of shrimp Sammy bought as a fraction of the number of shrimp Caden bought. Well, that's Sammy as a fraction of the number of shrimp Caden. That's just your first number over your second. Then it says, what is the ratio of the number of shrimp Sammy bought to the total? So Sammy bought 20, and the total was 32. E. What fraction of the total shrimp did Sammy bring? Okay. Oh, I put this in the wrong place. So they asked for a ratio here, which is 20-32. And then what fraction of the total shrimp? This should be down here. My apologies there. So they asked for a ratio in D, which is with a colon, and what fraction. 20 over 32. Okay, exercise 2. A food company that produces peanut butter decides to try out a new version of its peanut butter that is extra crunchy, using twice the number of peanut chunks as normal. The company hosts a sampling of its new product at grocery stores and finds that 5 out of every 9 customers prefer the new chunky version. Okay, so the ratio of number of preferring new extra crunchy to the total number surveyed is, now it's a ratio, so we're going to preferring new extra, 5 out of 9 prefer the new extra, so 5 out of the total 9. The ratio of the number preferring the regular, well, if you didn't prefer the chunky and you wanted to go back to the regular, if you didn't prefer the new one, which was 5, then there's a total of 4 left over. 5 plus 4 is 9. So if 5 preferred the new, 4 did not. And then the ratio of the number preferring the regular chunky to the number preferring the new extra chunky would be 4 to 5. And then the ratio of the number preferring new extra chunky, which was 5, to the number of preferring regular would be 5 to 4. And you can use colons or the word TO, so I'll just write TO that time just to remind you. And let's move on to B. Now it says let's use the value of each ratio to make a multiplicative comparison for each of the ratios we describe here. The number preferring new extra crunchy is blank of the total number surveyed. So now we're talking about multiplying by a fraction. So if I have 5 to 9, they're just asking for what would I multiply by to get a total. And it's 5 nines. Okay? And let me explain that further first. So let's say they're asking a multiplicative comparison, meaning if we ask more than 9 people. So I'm going to ask a multiple of 9 people. Let's say I asked 36. And I wanted to know how many preferred the new extra chunky. So I'd take 36 and multiply it by 5 over 9. Okay? And 36 times 5 is 180 divided by 9, which equals 20. So if 20 preferred it, then the remainder of that, 36 minus 20, is 16. 16 did not, so that would be a ratio of 20 to 36 on the total, or 20 preferred it, 16 did not. So it's just a multiple of 4. 5 times 4 is 20. 9 times 4 is 36. 4 times 4 is this 16. So we're looking for a fraction we could multiply bigger numbers by to determine that it's equivalent to this ratio is what this is asking. So putting this ratio into a fraction will tell us larger values that are still equivalent. Now it says the number preferring regular is 4 out of 9. Number preferring regular of those preferring new extra, so that's 4 out of 5. And then preferring new extra is 5 out of 4 preferring the regular. So it's just putting these ratios here in fraction form. C says, if the company is planning to produce 90,000 containers of chunky peanut butter, how many of these containers should be the new extra chunky variety, and how many of these containers should be the regular chunky, crunchy peanut butter? And what would help in solving the problem? Okay? So these fractions help in solving the problem. So we are trying to figure out how many want the new extra. 5 ninths want the new extra. So 5 ninths of 90,000. Okay, if I do it this way and multiply, it's always easier to reduce first. So if I reduce this, that 9 divided by 9 is 1. So I'm going to just simply, that's going to end up 1 over 1 or just 1. So I'm getting an integer here. And 5 times 10,000 is 50,000 jars. Should be the new chunky. And if I continue with this, then I would want to know how many want the old chunky, which is 4 ninths of 90,000. And if I put that over 1 and multiply these fractions and reduce the 9 first, That would become 9 over 9 is 1. So now we have 4 times 10,000, which is 40,000. So 50,000 new chunky, 40,000 of the original chunky would give us a total of 90,000 jars. So our comparison statement that helps us is comparing the preferred to the total. Okay, so moving along with this concept of peanut butter, now we're going to try these next scenarios. So try the next scenarios, pause the video, come back, and see if you did these correctly. Okay, so now that you've tried these, here we go. If the company decides to produce 2,000 containers of regular chunky peanut butter, how many containers of the new extra chunky would be produced? So I'm going to, again, take 5 ninths. Okay, so this is regular chunky peanut butter. So the regular chunky peanut butter is the 4 out of the 9. So I could set this up as a ratio. So if I said 4 is to the total, so it says how many containers of new extra chunky would it produce? Okay. Okay, so if we know that 4 out of 9 is regular chunky peanut butter, and we know we are making 2,000 containers of the regular, I can find out what the total should be if my ratios are equal. So I can think of it this way. What do I multiply 4 by to get 2,000? And 4 to multiply 4 times what to get 20? If we just look at the 20, 5 times 4 is 20, and then there's 2 zeros after it. So 4 times 500 is 2,000. So if I multiply the top by 500, I must multiply the bottom by 500, and 9 times 500 is 4,500. So that's the total number of containers we're going to make of peanut butter. But this is 4,500 is the total. And if I subtract the regular peanut butter, the original, they're calling it regular, I will get 0, 0, 5 minus 0 is 5, 4 minus 2 is 2. I will need to make 2,500 of the new extra chunky. 2,500. Okay? E. If the company decided to produce 10,000 containers of new extra crunchy, so that's the new 10,000, how many containers of regular would it produce? So now we're talking about the new extra chunky, and the ratio of new to the total is 5 to 9. And if I know I'm making 10,000 of the new, I can find the total. So then I ask myself, what do I multiply 5 by to get 10,000? Well, 5 times 2 is 10, and I've got those 3 more zeros. So 5 times 2,000 is 10,000. So if I multiply the top and the bottom by 2,000, I get 18,000 in the denominator, which is my total. I take my total of 18,000 containers, subtract the 10,000 new, and that's going to give me the regular, and 0,008. So the answer is 8,000 regular crunchy peanut butter containers. Okay, F. If the company decides to only produce 3,000 containers of new, so here we are, new extra crunchy, and we know the new is 5 to the total 9, and they're making 3,000 containers, how many containers of regular would they produce? So this is the same type of problem. We have to figure out what to multiply 5 by to get 3,000, and 5 will go into 30 6 times with those 2 other zeros remaining. So 5 times 600 is 3,000. And 9 times 600 is 5,400. So that's the total number we're going to make is 5,400. That's our total. And we're going to subtract the new and find out how many of the regular we're going to make. And the answer is 1,400 containers. I'm sorry, 2,000. 5 minus 3 is 2, not 1. So it's 2,400 containers. Okay. All right, lesson summary. For a ratio A to B, we are often interested in the associated ratio B to A. Further, if A and B can both be measured in the same unit, we are often interested in the associated ratios of A to A plus B and B to A plus B, which are the totals. For example, if Tom caught 3 fish and Kyle caught 5 fish, we can say the ratio of the number of fish Tom caught to the number of fish Kyle caught is 3 to 5. The number of fish Kyle caught to the number of fish Tom caught is 5 to 3. And then we can discuss it in terms of part to whole. Tom caught to the total is 3 to 8, and the fish Kyle caught to the total, the 2, is 5 to 8. So for the ratio A to B, where B cannot equal 0, the value of the ratio is a quotient A over B. So for example, for the ratio 6 to 8, the value of the ratio is 6 over 8, which could be reduced to 3/4. That is the end of lesson 7. Go do your problem set.